Alright, so now that everybody has the Qt Designer Creator installed on their machine, and they should have Visual Studio installed well, all you guys out there should have that. Um, what we need to do is we need to find the shell32.lib because we're going to be compiling this for a Windows application, and Qt Creator actually uses Win30 or shell32.lib in order to compile and build its graphical user interface. So what I've done here is I've actually searched for it inside of program files x86. Both the x64 and the x86 versions are going to be inside of program files x86. What I mean by that is the 32-bit is going to be called the x86 shell 32 lib, and the 64-bit is going to be called the x86 shell 32 lib. So I have my list of results coming from program files x86, and I'm using Windows 10, so all of them are coming from program files x86, Windows kits, /10/lib, and then what we have to be careful of here is if we actually hover over this directory, you'll see Windows kits 10 lib 10.0.10586.0/um/arm64. And that ARM64, that last directory that's on that directory chain, you want to pay close attention to that because ARM64 is actually more like an embedded device's CPU. And that would be for compiling for a 64-bit ARM CPU, whereas I actually have an Intel CPU, so I want to be compiling for x86 for Intel, the x86 architecture. So what I really want is I want to find where the 32-bit and the 64-bit shell 32 libs exist for my architecture, and they just so happen to exist one version below in 10,240.0 under UM x86 and UM x64 respectively. So I'm going to be showing you guys how to build a 64-bit application because that's just the way the industry is going. A lot of people seem to think that they need 64-bit even when they don't, and I think it's kind of an important distinction to make as a developer when you need 64-bit versus 32-bit, but as a customer, people are demanding 64-bit more and more. So we're going to compile this for 64-bit. So let's open this search result in its file location. That way we can add this shell32.lib into our Qt application when we create the solution or the project, let's say. So with Qt installed, I'm just going to type in Qt, and then Qt Creator Community comes up for me. And it's going to open this welcome page, and obviously we want to create a new project. Some of you guys might actually not even have a project created yet, or maybe you fiddled around in between watching part 1 and part 2, but this new project button obviously creates a new project. So we're going to click that, and I'm going to choose a Qt widgets application just to have the graphical user interface at our fingertips. Obviously a Qt console application will sort of save on that graphicality and maybe cut down on the memory usage and whatnot, but I don't really care. I'm going to use a Qt widgets application, and this is what you want for graphical user interface because they've got a nice designer. We're going to hit choose, and I'm going to keep it at the default name. I'm going to keep all of those Qt Creator kits. I'm just going to keep everything at the defaults so that everybody can, all you guys can follow along relatively easily. So now that it's finished creating the brand new project, the first thing that I'm going to do is I'm going to go into this projects, and we're actually going to switch what we're compiling for. Right now you see desktop, Qt, 5.5.1, MSVC 2012 32-bit, and obviously I want to show you guys how to compile for 64-bit, so I'm just going to click 64-bit build, and that's going to switch what we're actually building for. After that, you want to run qmake. You kind of want to run qmake every time that you change anything about your project, especially compilation status. So if you add libraries, if you add header files, you sort of just want to run qmake one more time just to sort of wrap things up in layman terms, I suppose. So now that we have that set up for 64-bit, I'm going to right click this untitled one, and I'm going to say add library, and this is how you're going to be adding the .lib files. So I'm going to click the external library and next, and this is just going to be for Windows because we're going to be using that shell32.lib. I'm going to take that search results that I had earlier. I'm going to copy that directory straight into here. Hit S to get down to the S's. Just scroll down and get that shell32lib in there. And you're going to see that it's going to automatically fill in the library file and the include path. If you didn't select the right one, it actually will not fill these in and you will not be able to hit next. So that's going to be something that you're really going to want to be paying attention to, is that you select the correct, which is x64 and shell32.lib. And I actually want to remove this add d suffix for debug version because there is no debug version of shell32lib, as it's basically set in stone for us. And if you have that add d suffix for debug version, you're going to get can't find shell32.libd, and you really don't want that. You want to be able to build your application, so just uncheck that. And what you're going to notice is that the .pro file, which is what's open here, this is how you tell what's open. You can actually switch around between documents through this drop down, but you're going to see this untitled1.pro is open, which just so happens to be listed in your project tree right here, right under that untitled1 project directory root, I suppose you'd call it. And what you're going to notice is that underneath Win32, the libs has been added for shell32. And this is pretty much the syntax for including a library. You're going to declare what system you're targeting, if you're targeting a specific system. Then you're going to say libs plus equals, which pretty much just means append a library. And then this is the syntax for the present working directory, and it's going to auto-generate this path for you. That way you really don't have to. But most of the time you're actually going to be just using the directory basically explicitly. And then it's going to give you this -l shell32. And this is the easiest way to include a library, is just to add it using the Qt designer. So with that out of the way, we have shell32. What we should be able to do is we should be able to go to build and run, hit save all, and our application should run. It should at the very least create this main window, which is exactly what we want. So the shell32 link actually worked. So we're just going to close out of this, and there's really no stop run, so you just sort of want to manage this kind of stuff on your own. So now that we have that shell32 lib in there, what we want to do is include the OpenCL implementation as well, because I'm going to be showing how to use OpenCL. So what we're going to do is we're going to right click on Untitled1 one more time, add a new library. It's going to be an external library again. Go to the library path, And this time under Program Files, I'm using a NVIDIA card. So we're going to go to NVIDIA Corporation, and under Installer 2, after I have installed the NVIDIA GPU Computing Toolkit, which you can get by going to you can get that by just going straight to NVIDIA's website and going to the developer section and just downloading the CUDA toolkit. And you can actually even just search in NVIDIA OpenCL, and then it will actually redirect you to getting the latest drivers, and then also basically you're just going to want the latest drivers and the GPU computing toolkit, because both sort of work in tandem. You just want to make sure that you have everything necessary. So underneath Installer 2, after installing all that required crap, I'm going to go under the CUDA toolkit, and then under lib for x64 it's going to be OpenCL.lib, and this is what you need in order to add OpenCL functionality into your 64-bit application. You need to choose the 64-bit route from the CUDA developer toolkit. I'm only building for Windows, so I just uncheck Linux and Mac, and I'm going to uncheck that add debug suffix to the library file because I don't need it. I'm going to hit next, and once again it's just going to append that libraries one more time. So now that we have this, we just have one more thing that we need to add, really, and that's going to be the OpenCL header file. So if I go over into my downloads, I've already downloaded the OpenCL headers master, which I believe is available through GitHub. Yep, it's right on GitHub. Available from the Kronos group. And once you extract that zip that you've downloaded from GitHub, to download the zip, all you gotta do is go up to OpenCL headers, and then you can just say download zip under clone or download, and you're going to get all those CL headers, which is good. That's what we need for this app. So what I'm going to do is the directory that gets extracted is actually the one that it gets extracted into is the one that you really want to be using. So what I mean by that is that the CL headers actually are looking for the other CL headers inside of CL. So you want the include path to be the directory that you extracted the CL folder from this headers master into. So if you look inside here, you're going to see OpenCL headers master, and when you extract that, it'll be called OpenCL headers master, but you want to rename that to just capital C, capital L. So now that you have both of those libraries installed and linked into your application, the Qt program is going to do all that linking for you using this syntax as basically hints to paths. What we're going to do is we're going to go into this main.cpp, And what you're going to see now is that when you type in include and then that, you can type in CL. Oh, but you can't. And here's the reason why. You want to actually go and run QMake again. Hit save all. And now you'll see the CL, CLH. So that QMake can be a little bit tricky sometimes. If you're having a very serious bug, you always want to run QMake and then recompile your application. I know that that's sort of a recompile, you're chasing your tail because you're recompiling and then you're running a make again, but for me that's the easiest way, and as long as you're competent enough to debug your own issues in your own code, it should be a very easy way of tracking down issues. So that's how you import the CL header and have the program realize all of the libraries and pull everything together for you. So I'm going to see you guys next time. Next time we're going to get into some actual coding, creating OpenCL contexts, getting our OpenCL devices, and then creating an OpenCL kernel as well. So I will see you then.